Let's move on to angles. You probably know a lot of the stuff we're going to cover today because you covered angles in middle school. So a lot of stuff you might already know, but still take your notes because that is part of your grade. So let's first define an angle. An angle is basically two shapes in geometry that we combine together. It's two different rays with a common endpoint. Okay, now for example, if you look at that picture, let's call that common endpoint A. Now you see those two rays, one's going up this way and one's going this way. They have that same endpoint A right there where they both start. Each ray is called a side. Okay, so because there's two rays, there's two sides, and so we're gonna name these sides. And for example, if I call, I pick any point there, call it B, then that ray AB is called the side. And then also this bottom part right here is also another side. So we're gonna name it. Let's put another point. We'll call it point C. And then AC, that ray on the bottom, would also be a side for that ray. Sorry, for that angle. Okay. So on your notes, go ahead and make yourself a note that the sides, there's two sides, and in this case, it would be ray AB and ray AC. And then that common endpoint is going to be called the vertex. Okay. So in this case, that common endpoint there is going to be A. So we can call that vertex A. All right. And then let's talk about naming angles. Okay. So there's going to be lots of different ways you can name an angle. And then sometimes you can use some of the naming, sometimes you can't. So let's go over that really quickly here. So for example, we can call this angle angle BAC. Now put your little hint over here, but the vertex, okay, that point A right there, has to be in the middle when you're naming the angle with 3 points, okay? Because sometimes you can use 1 point, and I'll explain the difference when you can use 1 and 3 points. In a little bit, okay, but you can call it BAC. That vertex has to be in the middle, okay. The other two kind of don't matter. So like you can go this way and kind of go BAC, or if I go this way, I can also call it CAB. But you do have to go like in a clockwise or counterclockwise order, okay. So you can also call it angle CAB. And then sometimes, but not always, you can use the vertex only. For example, angle A. But this one doesn't always work. Okay, and I'll give you an example why this wouldn't work in a little bit. And then sometimes you might even see a little number inside the angle, like for example, a 1 there. Then you can also call this angle 1. But sometimes you're not going to see the angles and you're going to see the points only. So let me tell you why this one here doesn't always work. Okay? Sometimes you might see more than one angle like so, and if I were to call this the vertex for all these two angles here put together, vertex A, if I were to say look at angle A, okay, you wouldn't know which one I'm talking about. You wouldn't know if I'm talking about this top angle A or this bottom angle A down here, or maybe I'm talking about this whole piece here. Which one am I talking about? You wouldn't know, okay. And so when you see more than one angle kind of put together with another angle where they have the same vertex, and you're gonna have to kind of be more specific. Okay, for example, I may call this B, and I might call this C. Now, if I call it angle BAC, then you know I'm talking about the one that passes through B, hits A at the vertex, and then goes towards C. You know I'm talking about this angle right here in the middle. Okay. So angles are measured in degrees. But basically, if you cut any circle into 360 equal slices, then one of those slices' angle would measure 1 degree. Okay, since there are 360 of those 1 degrees, then a circle always measures 360 degrees. Pretend I have a circle, and I split it up into 360 equal pieces, like these pieces here. So if you count all those lines, there's 360 lines in this circle here because we're cutting it equally into 360 lines. Let me show you how 1 degree looks like. Okay, so if I get the middle of that the middle of that circle and the center, and I draw a ray from that center to that 0 line. Okay, so far this is not an angle because we need two rays, but we have 1 ray there. If I draw another ray passing to that first mark, because we cut it into 360 marks, that little angle right there, That's the measurement of 1 degree. And you can get more than 1 degree. For example, if I open it like that, then that's 10 of these 1 degrees. Okay? So that would be basically 10 degrees. And I can do the same thing. I can get 45 of those 1 degrees, and then the angle will measure 45 degrees. Okay? And so on and so on. Okay, so let's do some examples. Write 3 names for the angle shown. Okay? So for example 1, I can call this angle, and you have to remember that when you're using 3 points, the vertex, in this case vertex E, has to be in the middle. Okay? So I can call this angle DEF, or I can go this way and kind of go FED that way, but E has to be in the middle. Or I can call it just angle E. And I can call it angle E because there's only one angle here. If I say angle E, you know I'm talking about this angle. Okay? I'm going to put one wrong. Do not, if you were thinking EDF, then this is wrong. Okay? Because EDF, I'm going to draw those points again here so you can see what EDF would look like. But if I draw the same 3 points, EDF would kind of go passing through E towards D and then towards F. Okay? So I'm going to show you what that looks like. It's passing through E, hitting D, and then going towards F. So it wouldn't be the same angle. It will be like this other angle going on this way, which is a whole different angle. Okay, so do not call it EDF, or don't even call it FDE for that same reason. For example B, it says name 6 angles, and so there's a lot of angles there. And the one you cannot use, like I said earlier, you cannot say angle F, because why? Because which one is angle left? There's a lot of angle lefts there, and angle left is not very specific. Okay, so like for example, I'm gonna call this put a 1 here, but angle 1 there we can call it AFB. So I'm gonna say angle AFB, or you can even put BFA. You can flip it around, but just make sure that F is in the middle. Okay, and if I call this angle 2, I can call this one BFC. And then we'll put a 3 here for this angle in the bottom here. I can call it CFD, angle CFD, and then angle 4 here I can call it EFD. But I can also give you this angle here, but this would be AFC. So you can also call another one AFC, or you can even use this one over here, this bigger one, EFC, and that's already 6. If you can think of more or different ones, it's fine. Okay, the interior of an angle. Okay, so interior just basically means inside. Okay? So the inside of an angle, it's going to be all the points that lie between the 2 sides of an angle. Okay? So I'll draw a little animation here. But this is all the points that are in between that angle. Okay, so any point inside there would be a point in the interior. And then for the next definition, exterior. Well, exterior just means outside. And exterior of an angle is all the points that are not in the interior of the angle. Okay, so basically everything on the outside over here, all that blue part is the exterior of the angle. And we're going to classify angles by measure, and this one you're probably familiar with these because you did them once again in middle school, and so you should hopefully know these before I even plug them in. Okay? But an acute angle is an angle with the measure below 90. Okay? So it could be like 89 degrees, 80, 70, anything that's smaller than 90. A right angle is an angle with the measure of exactly 90 degrees. Okay, so it measures exactly 90, it's a right angle. Obtuse is an angle anywhere between 90 and 180. And a straight angle is an angle with the measure of 180 degrees. Okay, so I'm going to show you that circle that I had earlier. And an acute angle, if you notice here, this red part is going from 0. And I stopped it right before the 90, because if I stop at 90, then it becomes a right angle. So any angle in that red zone will be considered an acute angle. So here's all these are acute, and right there you see it's about 89. So all those are acute, and once again, anywhere in between there is acute. For a right angle, it has to be exactly 90. And you can think of this as like the corner of a piece of paper or the corner of a book. All those books and papers have exactly 90 degrees, and they're considered right angles. We're going to do this notation here on the picture. Anytime you see a little square like that, it means that it's 90 degrees or it's a right angle. Speaking of right angles, why did the right angle go to the beach? Because it was 90 degrees. For obtuse angles, I drew you that little red part there. You see that it goes from 90 all the way up to, and not exactly 180, but it has to be less than 180. So I went up to about 179. Anything in here will be considered an obtuse angle. And then the last one would be a straight angle, and it's called a straight angle because it makes a straight line. From 0 there to 180, you can see that this is a straight line, or a pair of opposite rays is another way to think about it. But this is always going to be half of a circle. Half of a circle will always be 180 degrees. The angle addition postulate, and remember, postulate is just a rule that is kind of a common sense that we all agree on it because it just makes sense. Okay? But the angle addition postulate says if point D is in the interior or the inside of angle ABC, then something's going to be true. Okay? So before I give you the formula, let's look at this shape here. Remember that in order for this to be angle ABC, B has to be the vertex. So let's call that, let's go back. Point D is on the inside, so we're going to call that point D. And then point B is going to be the vertex there. And then A is going to be just any point, and C is going to be any point on those two rays. If I draw another ray going through it, then I have a combination of three angles. Okay? One on top, one on the bottom, and the whole big angle that's in black. Okay? And it's very similar to the segment addition postulate. I'm going to give you a picture here so you can see what's happening. But if I were to tell you what's the measure of the whole angle, okay, from here to here, how much degrees would that be? Okay? Well, it's just common sense that if I have 30 degrees and then I add 20 more degrees, and the whole thing is going to have to be 50 degrees. So the formula says that the measure of angle ABD, which is the top angle, plus the measure of angle CBD, which is the bottom angle, will equal to the measure of the whole angle. Alright, so I messed up on example number 2. There is no NPQ. So let's change it to angle YWZ. So on the picture here, YWZ is this angle here on the right side. Okay? How can I find that angle? Okay. Well, we can use the angle addition postulate. Says these two angles, this left angle plus this right angle together are going to equal to the whole angle. Okay? And if you notice, the whole angle is a straight line. And all straight lines are going to be straight angles which measure 180 degrees. Okay? So according to the angle addition postulate, once again, we can say 123.5, which is the left angle, plus angle YWZ, which is this right angle on the right side, will equal to the whole angle, which we said was 180. Now, how can I get YWZ by itself? Well, I can subtract 123.5 from both sides, and that will cancel out that left side. And I get angle YWZ, what it equal to. And then 180 minus 123 is 56.5. For example B, find the measure of angle FHG. So let's go up here to the picture, and FHG, if I follow F to H to G, we're talking about the bottom angle here. Okay? And they give you a hint here. It says they're giving you that the measure of EHG, which EHG is the whole thing, this whole angle is going to be 77 degrees. And so once again, the angle addition postulate says that the top angle plus the bottom angle together will equal to 77. So I can set up my equation as 9x plus 3 plus 13x minus 25. Those two angles are going to equal to the whole thing, which is going to be 77 degrees. Now just doing the algebra, I can combine like terms. 9x and 13x, if I add them together, it's going to be 22x. And 3 minus 25. 3 minus 25 is going to give us negative 22. This equals to 77. Now if I add 22 to eliminate that minus 22, it will cancel, and I'm left with 22x on the left side equals to 77 plus 22 is going to be 99. Then if I divide both sides by 22, this will cancel, and I'm left with x equals to 4.5. Now once again, this is not the answer, okay? Because they're not asking you to find the value of x. They're asking you to find the measure of the angle. Okay? So I'm going to have to do more work. And I know that the measure of the angle FHG, once again, FHG was the bottom angle, okay? This bottom part. And I'm going to put it here. It's 13x minus 25. Well, if we just found out that x was 4.5, plug in that 4.5 and subtract 25 afterwards. Sorry, I'm kind of choking here. 13 times 4.5 would equal to 58.5. Minus 25 would give us 33.5. Congruent angles. Congruent angles, basically we went over congruent last time. Congruent means like the same measurement. So congruent angles are basically angles with the same measure. On the picture on the right, if these were both, they say for example like 75 degrees or whatever they are, if they're congruent, you're going to put these little congruent marks right here. Like so. Okay, so when you see that, that means that they're congruent. And like the last time also, let's say I have two other congruent angles like this. I don't want to put one mark here because then this is going to suggest that this one is congruent to that one. Okay, so what we can do is we can put two marks like so to signify that these are congruent to each other, but not to the other ones. Angle bisector. Remember last time bisector means to cut exactly in half. So any line or any segment or any ray that cuts an angle into two congruent angles is going to be said to be an angle bisector. Okay, so I mean, it doesn't have to be a ray, but most of the times you'll see rays. And so if I draw a ray right through the middle here, let's say this was like 20 degrees and the bottom was 20, then we can say that these two are going to be congruent angles. And therefore this ray here is an example of an angle bisector. So for example 3, it says find the measure of angle JKL. So JKL is basically the whole angle. And it's saying find the measure of that angle if the interior ray is an angle bisector. So this ray here in the middle is bisecting the whole angle. It means that these two pieces are going to be equal to each other. Okay? So if that right side is 51, and this one also has to be 51. And so how much would the whole angle be? So the whole angle would be 51 basically plus 51. And 51 plus 51, sorry, the measure of the angle, 51 plus 51 is going to be 102 degrees. For part B, find the measure of angle ABC. Okay, so angle ABC, here's A, goes towards B. Oops, sorry, towards C over here. Same thing as the last one. This whole thing, how much is the measure of that angle? Well, we're saying that the ray BD is an angle bisector. So if this ray is an angle bisector, then this piece is being cut into two equal pieces so that these are equal. Okay, and if these are equal, then I can say that 5x plus 16 equals to 8x minus 23. And then I can do my algebra. So I'm going to subtract 5x. It's going to cancel. And I'm going to get 16. 8x minus 5x is 3x. Bring down the 23. Now I can remove that 23 or get rid of it by adding 23 to both sides. This will cancel. 16 plus 23 would be 39. And I get 39 equals to 3x. Then I can divide both sides by 3. And then this will cancel and I get x equals to 39 divided by 3 will be 13. Alright, but once again, this is not the answer because I'm trying to find the measure of the angle ABC. Okay, so I do have to plug in 13 back in here, and then or I can plug in 13 back in here, or you can do it in one of them, because remember these are both equal. Okay, so I can when I plug in 13 here, I gotta multiply 5 times 13 and then add 26, and 5 times 13 is 65. And if I add 65 plus 16, that tells me that this angle here is going to be 81 degrees. Now, if I also plug in 16 here, sorry, not 16, 13, then it also has to give me 81. Okay, go ahead and check it if you need to. But it has to be the same because it's an angle bisector. And so the whole angle, I'm going to put it here on the left side, is going to be 81 plus 81, which 81 plus 81 is going to be 162 degrees. Okay, so that's our final answer. The measure of the whole angle is 162.